So we're going to talk about a few more components that you commonly see in circuits that we have in our kits actually. Switches and potentiometers. Right here we've got switches, push buttons and switches. They're basically serving the same purpose. Now on the left side of the screen you see a switch. There are many different types of switches, okay? Many different looks, but that's one right there. That's called a rocker switch. But there it is, and you can see below it, you can see what its symbol looks like. It's basically just a little, like, I don't know, a door on the circuit, right? And then next to it, you see a push button, which you actually should have a push button like that in your kit. Push button serves a similar purpose, and that its symbol is below. Now, the point of a switch and a push button, of both of them, is really to complete a circuit, to close a circuit. So understand that if you've got a battery, let's say, and you got wires coming out of the positive and negative side, if those two wires are not connected, you don't have a circuit, no flow, no current flow. You got to have a full path from positive to negative. So if you put a switch in between that path, if that switch is open, meaning it's off, right, then the switch is open and the circuit is not connected. But if you close that switch, or if you push that button, which is doing a similar thing, you push that button, then that connects the two ends of the circuit, and it makes a complete path from positive to negative, and you can get flow. So this is how push buttons and switches are used, right? They're used to close circuits. So basically, if the circuit is open, no current will flow, nothing's going to happen. You close the circuit by flicking a switch or pushing a button, and then current flows and something happens, whatever you want to have happen. So those are switches and push buttons. It closes the circuit. Note that these switches that we're showing, okay, so let's look at the switch on the top left, right? That switch, it's got two terminals, right? One left, one right. And when you flick that switch, those two terminals are connected. So when the switch is off, the two terminals are not connected. When it's on, then the two terminals are connected. When those two terminals are connected, their voltage is exactly the same, right? It's a consequence of Ohm's law, right? If there's no resistance between 2 points, or actually not Ohm's law, it's Kirchhoff's voltage law, but different law. But if you got 2 points and they are connected with no resistance in between through a switch like this, then they will have the same voltage. Where if they're not connected, then they can have different voltages. Now, and one note I should just bring up right now, that push button, the push button that we have there, that actually is very similar to the one you have in your kit. That thing has got 4 legs on it. It's hard to see. You can only see maybe 3 of them here, but there are 4 legs. So it doesn't really just have 2 terminals. This one has 4, but 2 of the terminals are connected to each other. So the 2 on the left are connected to each other, and the 2 on the right are connected to each other. So when you press the button, the 2 on the left become connected to the 2 on the right. But there are many different varieties of switches and push buttons. But now, potentiometer. Now, this is an interesting component. We've got one. There are many different looks for potentiometers. I believe yours looks like this one. Now, this potentiometer, hard to see, but it has 3 leads in it. Now, the blue thing, that's a potentiometer. And notice it has a knob. Hard to see, but it has a little knob that you rotate. All these potentiometers, they have something that you move. Either like a rotary potentiometer like this one has a knob that you rotate. You can have sliders that go back and forth that do the same thing, right? Now, it has a schematic symbol, and you see that in the middle there. So it's like basically a resistor with a little arrow in the middle, right? That's a potentiometer. That's its schematic symbol. And notice that schematic symbol has 3 leads also. The resistor has a top lead, a bottom lead, and then there's that arrow, which is the 3rd lead, right? So the 3 leads on the potentiometer correspond to those 3 leads in that schematic diagram. A schematic symbol, rather. Now then, over on the right, that circuit that we have there with the 2 resistors and with the voltage in, the voltage out, and all that, that is the circuit that I'm going to use to describe the behavior of a potentiometer. Okay, so because a potentiometer acts like that circuit. Okay, that's what I'm telling you. That circuit is called a voltage divider. Okay, so so remember the potentiometer has 3 terminals. And that circuit's called a voltage divider. Now, if you look at that circuit, at the top, there's this V-in, okay? And at the bottom, there's ground. So those two, V-in and ground, those are 2 of the leads on the potentiometer. The top lead and the bottom lead on the potentiometer are the V-in and the ground. And then the middle, that little arrow in the schematic, that is that V-out right there. That's what you're actually measuring, typically, okay? So the resistance from the top to the bottom, V in from one side of the potentiometer to the other, so from V in to ground, that resistance is constant. no matter what. You turn the knob, the total resistance from the left side of the potentiometer to the right side of the potentiometer, or top to bottom, is going to be constant. Now, the total resistance from V in to the ground is going to be R1 plus R2. Those two resistors added together, that sum is constant. So, for instance, if you got a potentiometer and it is a 10K potentiometer, 10 kilo ohm potentiometer, then the sum of those two resistances from one lead to another is always 10 kilo ohms. But what changes is that V out right there. Because what changes is as you turn that knob, the ratio between those two resistors, R1 and R2, the ratio of their resistance changes. So if you turn the knob one way, R1 gets smaller and R2 gets bigger, even though the sum stays the same. And you can turn the knob the other way, and the reverse happens. R2 can get smaller, R1 can get bigger, but the sum stays the same. So as you turn this knob, the voltage that's observed at V out changes as you turn the knob. Because what happens is that voltage, okay, let's go back to our Ohm's law, right? V equals IR. So we want to measure V at V out, that point V out, right? In between those two resistors. That V equals I times R, right? Now I is the same for both resistors because it's only one wire that everything's going through, but the R changes, right? If you can make R get bigger and smaller, R2 specifically. The R2 is the resistor between V out and the ground, okay? That R is changing as you turn the knob. So since V equals IR, if R is changing and current is constant, then V is changing. So as you turn this knob, you're changing resistance, which changes the voltage that's perceived at V out. So that's how we're going to end up using potentiometers in general. And I'll show you a circuit like that. Thank you.